We talked about binary search trees, which we saw that at any given point in our tree, we have to do a big O of k comparison, and theoretically we would have to compare big O of log n potential elements. So if I was storing n elements of length k, in the worst case, a binary search tree would be big O of k log n, which is not bad, but one issue is that it scales with n. Not linearly with n, but still, as n gets bigger, the performance of my binary search tree will get slower. But one benefit was that it was memory efficient. I don't have very much wasted space at all. With the multi-way try, on the other hand, we figured out that we could store a bunch of words such that if I was looking for any specific word, it would be big O of k, regardless of how many words I actually stored in my multi-way try. I could have 1,000,000 words versus 10 billion words. It would still be big O of k to search for a single specific word. However, the problem was that it's very memory inefficient. In order to maintain this performance, I have to have a bunch of wasted pointers to be able to do constant time access at any given node in my multi-way try. So it is super fast with respect to n, but at the cost of a bunch of wasted memory. The ternary search tree, or TST, is another data structure. It's another search tree that's somewhere in between these two. It has an algorithm of storing words very similar to a multi-way try, but we're able to have much less wasted space with regard to pointers by using what's effectively a BST-like search down our tree. So here is an example of a ternary search tree. And this ternary search tree is containing 4 words. So similar to the multi-way try where we had a special word node indication, in a ternary search tree, we also have a special word node indication, which I've marked as pink in my tree. So nodes that are pink represent the end of a given word. So the ternary search tree, this looks kind of funky, but let's break it down. Basically, to be able to use a given letter at the current node that I'm at, I either have to take the down traversal edge of that node, or if it's a word node, I can use it and stop. So equivalent to like taking the down edge, but just stopping. So what does that mean? Well, let's actually enumerate the different words in this specific ternary search tree. And in a later video, I'll show you the formal find algorithm. But basically, for TST trees, for ternary search trees, I start at the root, and then let's say I want to go down this way. So if I'm at the root, my current node is letter C. I want to use it, so I'm going to go down. Now I'm at A, I want to use it, so I go down. I'm at L, I want to use it, so I go down. And now I'm at L, and I want to use it. It's a word node, so I can just use it and stop. So call is one of the words in this TST. Let's try another word. I'm at the root, and I don't want to use this downward edge this time, which would force me to use that letter. This time I want to explore this subtree. So from the root, I'm going to go to the right. Because I didn't go down, that means that I do not use the C. So I went right. Now I'm at M. If I go down, that means that I'm using the letter that I was at. So going down at M means I've used M. And then now I have a word node. So if I use it, I can stop there. I can stop and use it. So this is another word. Let's try again. So starting at the root, I can go right. Because I didn't go down, that means I don't use C. So now I'm at M. Now I go down. So that means I have to use the M. And now I'll traverse this subtree that I didn't see last time. I go right, which means I do not use E. I would only use E if I stopped or if I went down. So I go right, which means I don't use E. Now I'm at I. I go down, which means I use I. Now let's say I go down. That means I would use N, because I was at N and I went down, so I use it. Now I'm at D. I'm going to stop because this is a word node, and I've used it. I don't have to necessarily stop at a word node if it has children, but I could choose to stop at a word node, which means I have to use that letter. It's equivalent to going down, but you just stop. Okay, last one, because I have 4 word nodes, which means I must have 4 words. So I start at the root, I go to the right, which means I don't use C. I go down, which means I use M. Now I'm at E. I go to the right, which means I don't use E. I'm at I. I'll go down, so I use I. I'm at N. Last time I went down this way, let's try going left. I go left, which means I do not use N. I can only use a letter if I go down or if it's a word node and I choose to stop. But I went left, so I don't get to use N. So I go left. I'm at D. Because this is a word node, I have the choice of stopping. I don't have any children here, so I might as well stop. So I'll just stop, which means I have to use it. So this TST has these 4 words in it.